Hello, I'm Ken Shelton. I'm going to explain to you how to use your electric pottery kiln. Firing program is what controls the rise of heat within a kiln up to the top temperature, and sometimes will control the cooling as well. And this consists of various segments or parts of the program. The first part of the program would be a delay start, and program controllers will give you the ability to delay the start of a kiln, and this will enable you, for example, to set the kiln to come on at the early hours of the morning, so that by the time you come into work it's achieved a certain level of temperature, for example 400 or 500 degrees, which would then enable you to put the bung in the flue on top of the kiln, as we discussed earlier. So that's a delay start. Then the program starts properly in that it starts to heat up, and we call this the first heating ramp, and this is defined by degrees temperature per hour. An example would be 50 degrees an hour is a slow heating rate. 200 degrees an hour would be a fast heating rate. Now this is the first heating rate, so you need a target temperature for that. The target temperature we normally set at about 600 because that works for most heating programs. So you've got a starting temperature rising gently up to 600 degrees. Now at 600 degrees you have an option for a soak, otherwise known as a dwell. And this means a short period of time where the kiln is held at one temperature, at that 600 degrees. And that may normally be about 10 minutes, 15 minutes, just to make sure everything's evened out. It could be longer for certain specific products or programs. After the soak or dwell, you go on to your second heating ramp, and the second heating ramp is usually a lot faster. This is because it's safe, because at 600 degrees you've driven out the moisture and you've burnt away the gases and combustible material within the clay. If you were to go fast from the beginning of the firing program, you might well find that you're boiling moisture, chemically combined moisture, that's still within the clay. And when that boils, that turns to steam, and that can cause the pottery to explode. And that is the most common cause of failures in pottery, particularly in schools, where you have quite chunky pieces which are holding a lot of moisture within them. So the first heating ramp up to 600, second heating ramp faster, because it's safe to go faster now, up to your top temperature. The top temperature is the temperature which matures the clay that you're using, and you need to talk to your manufacturers about the particular clay that you're using to be sure that you've got a maturing point for that. The top temperature, an example we'll look at shortly, is given at 1120, and that will be followed by another soak or dwell for a period of 10 or 15 minutes, usually, something like that. After that, the controller will stop heating the kiln, and the kiln will cool down naturally. This is the usual process, but it is possible with some controllers to allow to control the cooling of the kiln, and that's in some unusual type of glazes, in macrocrystal glazes, for example. It's very useful to control that cooling, and certainly in work with glass you would always control the cooling very carefully through annealing phases. Typically in ceramics you don't bother to do that, you allow it to cool down naturally. The way we control the firing program is through a program controller. You'll see that the temperature on the outside is showing 22 degrees. This is the ambient temperature within the kiln, as measured by the thermocouple, which is the small probe that we looked at earlier. And I'm going to step through the segments of the program to see what's been fired last. by pressing the right facing arrow, I see that program number 8 was fired last. Now this controller has 10 programs. This is program 8 of those 10. Many controllers only have one program, and others have many more programs. Program 8 contains, pressing the right facing arrow, first of all the possibility of a delay start, which isn't being used in this instance, so there is no time before the kiln starts to heat up, hence it's passing through that segment. I press the right facing arrow again and I come up with the first heating ramp, and this is at 50 degrees an hour. It's a nice gentle warming up, and that's going up to the target temperature of 80 degrees, and at 80 degrees an hour it's going to soak or dwell, in other words hold that temperature for 30 minutes. And the point of this particular program is to ensure that any remaining moisture is being driven off evenly and slowly without coming to the boil. If that moisture should boil, of course, as I've just said, it will cause the ceramic to shatter into pieces. The next segment, we start off a little bit faster. It's 100 degrees an hour, and we're going to maintain that temperature to a temperature of 600 degrees. 600 degrees is your target temperature for the second heating segment. And at 600 degrees it's going to be held there for 10 minutes to ensure that all the pottery is warmed through evenly. So having reached the 600 degrees, you can then move forward at a faster rate because the piece is safe. So 200 degrees an hour now, twice as fast, up to the top temperature, the target temperature. This is as hot as you're going to get the clay. It's 1120 degrees in this instance. And at 1120 we're going to hold it there for a soak of 10 minutes. Now that would be sufficient to mature the clay in this particular instance with this particular type of clay for a bisque firing. The bisque firing is the first firing, and that's the firing that converts clay into a different chemical substance altogether, ceramic. Now, if I press the right facing arrow to step through this program, you'll see that after that it says the word end, and that literally tells me that that's all that's been programmed in that controller. It is possible with certain controllers to have cooling ramps as well, and this means that you can control the cooling down of the kiln. In ceramics it's not usually used, but it's certainly used all the time with glass making and with certain kinds of ceramic glazes such as macro crystals, for example. The other thing about controllers is that you've got a series of diagnostics as well. So if things go wrong with the kiln, then the controller will usually shut down and then display an error message. And the sort of things that can happen are, for example, if you have a power cut. Now, if the power cut is not too long lasting, then the kiln will come back on again. If the kiln drops a lot in temperature, usually by about 100 degrees, then the controller will shut it down and not start when the power comes back. But you will tell when you come back to the kiln that there is an error message telling you that what has occurred. Typically other things might be a broken thermocouple within the kiln. That would stop the controller measuring accurately what was going on inside the kiln, so that would throw up another error message as well. Controllers now are protected against power surge. So for example, if there was a power surge through the controller, that would be protected, but anything harmful, the controller would be shut down and you would have an error message showing that. The most important thing that controllers can do from the point of view of safety is protect against overfiring. So should your controller be firing, or should your kiln be firing out of control for whatever reason through mechanical failure, and it hits 20 degrees hotter than the temperature set, then the controller will shut the kiln down at that point. And this will prevent an overfire within the kiln. And obviously a most important aspect. Overfires were something that were very common in the early days of electronic controllers and almost unheard of now through these safety devices. I'll have a look at how the controller works in the sense of changing the program and altering values within a program. First of all, we need to turn it on there. It's powered, of course, taking its power from the kiln. When you first turn a controller on, it goes through a series of displays which tell you the type of controller it is, the type of software that's present. And then you arrive at the temperature within the kiln itself. At the present moment it's 20 degrees. You've seen before how we step through the programs by pressing the right facing arrow. I've got program 8. Okay, if I don't want program 8, I want program 9, I press the arrow facing upwards. Similarly, pressing the button facing downwards, I can step through all of the programs down to number 1. Looking through program 1, we've seen this before, pass means there's no delay start. If I want to put a delay start, I can press the up arrow and I have a minute, 2, 3, 4, and by holding it down I can scroll up to the value I require. Remove that and it's come on to pass. We step through the segments. Down arrow, up arrow alters whichever segment you're viewing, and you view the segments by pressing the right facing arrow. Once you've made an alteration to your program number or to a segment within a program, with this controller you need to store that in the memory, and the way that works is that you press the stop start button once. That press now stores the change in the memory, and by stepping through using the right facing arrow you can check that everything is as it should be before you go. Other kinds of controllers have different methods of storing an alteration, so be certain that you check with the manufacturer's manual before you make any alterations. Controllers are connected to the kiln through a multi-pin socket on the side of the kiln here, a multi-pin plug. This is called a Harting plug and socket, and this is the common way that all kilns now are connected to the controller. What this means is that if you have a problem with a controller, you can very easily unplug it and return it to the manufacturer. Other controllers are available, and I'm going to put this one in place to show you. Connects through the Harting plug and socket arrangement, as you've seen, with the multi-pin there. Lift up the catch, slide it into place. It's a different looking controller, but it works principally in the same way as the one we've been looking at, by stepping through the segments that are within the program, and then any value can be altered by pressing the up arrow or the down arrow, and this will have the same error messages, the same diagnostics as the other controller we were looking at. I hope you have found this video informative. For more information, please see our website.